Hey brother, what's up? It is currently the 7th of November, the year of the Lord, 2016. Today is Mechanical Monday, and as 7-Eleven, it would probably be a more interesting day if it weren't for the election tomorrow. But nonetheless, I am back. You may have noticed that I was gone, which is necessary before one can come back. That's my attempt at positive spin. I was off visiting Canada and working on other projects and barraged by a legion of birthdays. So I was not able to do much work on this project at all. But it is time to turn that around, and I'm going to do so by starting where I left off, where I was rewriting kind of the algorithm behind trading in the game, because it was a little bit broken. Some cool things I've done is I have done a lot of refactoring and put a lot more of the logic, taken the logic out of my screen class and put it into the merchant class. I will have that posted on GitHub later this week so you can take a look if you so choose. I have also made the merchants smarter. They now look at the value of items based on the quantity and the type of item, and they will gauge the value based on whether it is an object they desire or an object that they do not desire or produce or provide. So if I'm a farmer, I'm going to value food less than, say, vehicles or a tractor, because a tractor is something I cannot produce. It is something I need. It is useful to me. Food, I can make lots more of food, so it's less valuable. I'm less willing to trade for food, and I'm probably going to give you a better price than the auto mechanic is if you ask him to sell you his lunch. So I have made the merchants a little bit smarter, but I was still running into a lot of trouble with trying to make the merchants trade fairly. And this, I must warn you, is where we get into a little bit of math. So I've got my handy dandy notebook. It's very high tech. If I can get it onto the camera here. Suppose we have merchants A and B. We like to suppose things when we do math. So the equation for profit from B's perspective is when, and you can't really see the subletters here very well, but when B sub Q, or the quantity, times the value, the inherent value of the object, is less than the quantity that A is providing times the value. So if I am this is just a mathematical way of stating something that's very simple. If I am a pair merchant, a purveyor of pairs, I will, and I offer you 3 pairs that I value at $5 each, so that's $15. I expect to get more than $15 in return. Otherwise, it's not worth my time. So, if you're giving me, I don't know, rutabaga, and I value a rutabaga at maybe $2 a pop, so I expect at least 8 rutabaga to come out ahead here. Now, as a side note, and I don't want to get into the theory of stuff here because it turns out that's very long, complicated, and interesting, and this is supposed to be a short video, is that this value is determined from the perspective of B. A is doing the exact same thing and seeing, is this profit? And I did the math, ran some scenarios, and it is very possible for 2 merchants to come together and both think they're getting a profit when they exchange goods. It's kind of cool. So that simple is a simple relationship that tells us whether we're making a profit or not. All right? Pretty straightforward. The tricky part is that when I use this, the merchant would sometimes propose things that were ridiculous, ridiculously unfair. So the merchant would say, well, hey, if you give me a car, I'll give you an apple. An apple is normally not worth as much as a car, and it's a ridiculous trade. And the merchant would also accept ridiculous trades that the player provided to them. And this was kind of lame because you could misclick or click too quick, and the merchant would really take advantage of you. I I want to try and remove that. I may end up adding it back in and add a, are you really sure mechanic for the trader? And that might be another way to make it fair, but I wanted to see mathematically how do we, how does a computer get a sense of what is reasonable but still profitable? And so the way you do this, it turns out, is a very similar equation, which again is super small, but if you read it here, it's essentially as long as the total value of A is less than the total value of B times a scalar of what is, we can call it as fair. So this puts an upper bound on it, and I'm going to use, in my examples, I'm going to use a scalar of 2. So as long as I'm at least giving you half of what something's worth, it's fair. Not really, but we could make that 50%. So as long as I give you, as long as I'm exchanging $20 worth of goods for $30 worth of goods. Ignore my math there, but as long as I'm doing that, I at least won't feel bad. If I ask for 35, then okay, I'm going to start feeling guilty because I'm really ripping you off at that point. So that's really the way this should be done, is by saying the upper bound is what I expect is the most the other merchant will give me. But that's complicated, and so I'm not going to do that right now because I've got a whole lot of other things I want to get in by the end of the month. So I was trying to figure out how do I teach the computer how to do this, because what you find is when the player proposes something, you have to match it, and that's relatively easy, right? I just find a number that is above my lower profit bound and below my upper fairness bound, and that's the item they need. It's not quite as easy if the player proposes a deal and I have to adjust it as the computer. And so I was thinking about this, and I'm going to switch over to the other view now, for reals this time, and show this graph. So it turns out, with a little bit of modification, we can show the profit curve here as a graph, where y is the number of items that are being sold. I'm sorry, the number of items that A is giving, and X is the number of items that B is giving. So in order to have a profit, I must, and you kind of, we can't give halves of items in this game, so you have to round. But so if I'm going to give, say, if I'm going to sell as B, if I'm going to sell 5 items, then I expect to get at least 4 to make a profit. See how that works? Anything above this line is a profit. Now, multiplying this by our scalar, in this case 2, gives us a fairness line, which is in purple. And so anything below this is fair, and you can see that since this is based on a scalar, which is really a percentage, the amount of variability you have grows with quantities. Now we can't increase indefinitely, so I'm also saying, well, I may have at most, I can't trade 0 items, that doesn't make sense. It only makes sense after 1. But I may have up to 50 items to trade, and I'm actually going to decrease that down to, say, 35, so it's on the screen here. And the other guy may only have 20 items. So this software doesn't let me shade in a region, which is unfortunate because that would illustrate my point rather well. But you can see some interesting facts, is that the most profitable point for B is going to be when I am trading 16 of whatever I'm trading for 20 of what the other guy's trading, right? It's fair, it's within his or her limits, right? They can actually sell me that many items. Or I'm sorry, y is equal to 20. Yes, they can sell me that many items, and I get the most profit. But I can go down to receiving 11 items, and I can still make a small profit. It's not going to be very big, and it's not going to be my leading offer, but it's something. So anything in this region is fair. So once you have that translated to a graph, it becomes a little bit easier to work with the math behind the scenes and explain this scheme to a computer. So if I am going back, if I get a point that's out here, I know, oh, I need to bring this down, right? If I get a point that's up here, I need to bring it up. If I've got, I can't have points that are outside this box here because if I don't have enough items, or they don't have enough items to make that work. So I thought this was kind of cool. It illustrates some of the math that I'm doing in the background and some of the headaches I'm dealing with. Once I start adding more factors, like whether the merchant provides or desires this item, you start seeing modifiers so that it's not quite as simple as as y is equal to 12, or 12x over 19. It becomes a little bit more nuanced. So, anyways, I thought that was cool. I look forward to seeing your runner game when you get a demo up and working. And until next time, I remain your brother.